Hello dear students. Today in this lesson we are going to talk about parallel lines and angle facts. So let's continue and try to understand a very important topic which is called transversal. Students, transversal is a line which intersects two or more than two lines simultaneously. So look at the examples here. Every red line over here is a transversal, because in each example this red line intersects two or more than two lines together or simultaneously. Okay, and don't be confused with the intersecting lines. Let's say if you just have two lines, there is no third line. Okay, so none of them are transversal, they are just the intersecting lines. A transversal is something which intersects two or more than two lines together. Okay, so just like the red one here intersects two lines here, two here, and even three here. All the red lines are said to be transversal. Let's continue now and try to understand when a transversal intersect parallel or even non-parallel lines, which all are the angles formed. So basically, when we have a transversal intersecting parallel, the lines could be even non-parallel. The angles name will still be the same. So mainly we have three pair of angles we'll be discussing. Alternate angles. We can further divide them as alternate interior angles and alternate exterior angles. Then we have co-interior angles or consecutive interior angles, as well as corresponding angles. And don't be confused just for parallel lines. These names are true even if we have non-parallel lines. Let's say we have two non-parallel lines, we still have all the three or even more pair of angles that we'll be discussing. So that's non-parallel line, and we have a transversal. Once the lines become parallel, now there are some special qualities, special traits that we need to discuss. We'll be discussing in our next examples. So students, let's continue with the first kind of angle, which are called alternate angles. Remember students, even if the lines are non-parallel, we can still call the similar kind of angles as alternate angles. The difference will be that the angles won't be equal. Just like you see here, the two angles are equal, and in the same way we can consider these two angles. They are still called alternate angles. But let's say if this is, for example, 30 degree, just an example, it could be suppose 45 degree. So they won't be equal actually, right? But they're still called alternate angles. Now students, we can further categorize them as alternate interior angles and alternate exterior angles. So students, the example we see right now are called alternate interior angles. Why? Because we see the angles lie in the interior region of the parallel lines. On the other hand, let's say if we have the same example and we have two parallel lines and the transversal intersect them, and the angles are formed somewhere outside, they're still on the opposite sides of the transversal. So if this angle is suppose x, this will also be x. Why? Because the lines are parallel, and this time the angles are called alternate exterior angles. Why? Because they lie in the outer region or in the exterior region of our parallel lines. Okay, so we have two types of alternate angles: alternate interior angles or alternate exterior angles. There are two possibilities in both of them. If this is the one pair, we can have another pair. Let's say we have this angle right here, so we can consider another angle which is equal to that. So if this is y, this is also y. So x and x are equal, similarly y and y are equal, and they both are the pairs of alternate exterior angles. In the same way, we just like have a and a equal, we could have had another pair in the interior region. Let's say if this angle is b, this would also be b. So we would say that yes, angles are alternate interior angles and they are equal. Why? Because they are made between the two parallel lines. If the angles are made between non-parallel lines, they are still called alternate angles or alternate interior angles, but this time they won't be equal because the lines are not parallel. Okay, so let's continue with the next kind of examples, which are called corresponding angles. Just like we have alternate angles equal between two parallel lines, if the lines are parallel, so the corresponding angles are also equal. But again, if the lines are non-parallel, suppose, and the angles are formed in the same way that they lie in the same direction, say this angle and this angle, they are still called corresponding angles. But definitely if this angle is A, that could be B. They are not equal in that case. Why? Because the lines are non-parallel this time. On the other hand, if the lines are parallel, the corresponding angles are equal. They are formed on the same side of the intersecting transversal. Okay. Now it's just not only the one pair, we can have total 4 pairs in that situation. Let us now have a look. This is one example of corresponding angle. We could have had this pair that is also equal. Let's say this is X, so this would also be equal to X. We can consider, let's say this is another pair, this is Y, so this will also be Y. And one more possibility is there, students. If this angle is Z, this will also be equal to Z. So there are total 4 pairs of corresponding angles. Let's continue with the next example, where we have like next kind of angles, which are called consecutive interior angles or co-interior angles. Students, that is the condition we only consider mainly between the parallel lines, because in non-parallel lines we don't have any much significance in that. So well, we have two parallel lines. Again, they are not equal actually. They're called same side interior angles as well, or allied angles also. So what happens here? We have two angles made on the same side in the interior region of the parallel lines. So if we add the two angles here, they are supplementary. Supplementary means their sum is equal to 180 degree. This is the one possibility. We can have another possibility. Let's say this angle is, say, M, and this angle is N, and the lines are parallel. So we can have other pair, again supplementary. M plus N will also be equal to 180 degree. And these angles M and N, or G and H, are called the pair of consecutive interior angles or co-interior angles. Now we just discussed a few methods, a few kind of examples of different types of angles. Let us now practice them with questions. Look at this. This symbol is called theta. It's a Greek letter, okay? And it simply represents an angle. Now we want to get the value of theta. If you look at the example, students, the two arrows represent that the lines are parallel. That's okay. But this angle and this angle, they are not directly related. However, we can correlate with some other examples we have discussed in our previous lessons, like vertical angles, linear pair angles, etc. So we can even associate them with that. Okay, so if this is 50 degree over here, one more thing, we discussed earlier that if the two lines intersect like this, so they form equal angles in the opposite side, right? And they are called the vertical angle. So if this angle is theta, this should also be theta. In that way, we can consider this angle should also be theta. Why? Because these are the vertical angles. And now look at this. The same side interior angles we just discussed. Whenever we have same side interior angles, they are called co-interior angles. And they add up to 180 degree. So we add them to 180 degree. And then we subtract 50 from both the sides. It's an equation only. Now 50 and 50 get cancelled from the left hand side, and then we are left with theta on the left hand side. On the right hand side we get 130 degree. So that's the value of theta, and this is how we solve that. Okay, let's continue with the next example. Again, we have the similar situation, students. Theta is there, we don't have any direct relation. However, we can do either the vertical angle method that we just used, Let us now have another method this time for the similar kind of question. We have a linear pair kind of rule that if you have a straight line and we make two adjacent angles on that, they still add up to 180 degrees. Suppose if this is x, this is y, so x plus y equals 180 degree. You already know that. So if one of the angle is 120 here, definitely say this angle is, for example, x. So by the linear pair theory, we have 120 plus x gonna be equal to 180 degree, and when you simplify this you get x equals 60 degree. Now students, look at this. If you just focus on the angle x, this angle, and this theta, aren't they kind of corresponding angles? Yes, they are. They are the corresponding angles. So you could say that theta equals x. Why? You can even write the reason that the angles are called corresponding angles, and just because they are made between two parallel lines, we can consider them to be equal. So just because x we figured out to be 60, theta is also going to be 60 degree. So this is another method of doing the same kind of question. Let's continue to the next example. This is a bit tricky one. We have three lines, and look at the line that intersect all of them together. Yeah, so this line, you notice I can highlight this line. Yeah, one moment. So this line we have over here is the transversal. Even the other line can also be considered to be transversal because it intersects two lines together. Well, no problem. So we have one of the angle to be theta here, and we can also consider, we can even extend that for our convenience. Let's consider this line to be here like that. Okay, and now we can consider this is 110 degree given, this is 35, this is theta. We need to figure out the value of theta. It doesn't seem to have any direct relation. However, we can correlate a bit with some theories. So students, you notice that this blue line has this 110 degree. Its adjacent angle must be supplementary, right? Supplementary means they will they'll add up to 180 degree. So if you consider, suppose this is my one of the line given, and now I can consider one moment, I can consider that there is another line on that like this, or let me just use a simple line, or I can just use this line. Okay, this is 110 degree. So this angle, students, by default you can say 180 negative 110, that becomes 70 degree. Okay, so once we got the 70 degree, we can write that, okay, this is my 70 degree. It's very tiny, but hope you can understand that this is 70 degree. Once we got that 70 degree, students, we also have learned the triangle sum theorem or angle sum theorem in a triangle. Whenever we have a triangle, all the three interior angles add up to 180 degree. The figure is not to scale, but you can understand that this is 70 degree, this is 35 degree. Okay, I just magnified this triangle. We can now get even this unknown angle. Let's say this angle is we can use any symbol. Suppose say this is A, for example, right? If this is A, we can still use the angle sum theorem. A plus 70 plus 35, they still add up to 180 degree. We simplify this equation, it becomes 105, 180. When you subtract 105 from both the sides, you get 75 degree. Okay, once you got 75 students, now just focus on the two lines. Now just forget about the other lines. I'll now highlight the lines that we need right now. We have another line here. This is my another parallel line. This is the another parallel line, and now I can color the transversal like this. If you notice this situation, students, the green and the red line, we have angle A and theta. If I now extract this diagram outside, we have, suppose, let me just scroll down a bit, and we have this transversal, and we can consider that there is one parallel line like this, There is another parallel line like that, and we have a theta and a. We just only focus on theta and a. So this is my a. Okay, that's what you see here. This is your angle A, this is the theta, and they are kind of co-interior angles, right? So they will add up to 180 degree. A plus theta will add up to 180 degree. A means the angle we just figured out from the triangle is 75 plus theta equals 180. When you subtract 75 from both the sides, you get 105. So theta is 105 degree. This is how we solve this question. I hope it's clear, students. We'll have a few more complex questions in the next video. Till then, bye-bye.